This is Narendra. I'm here to share with you the topic electrostatics. Firstly, let me tell you that there are two kinds of electricity: static electricity and current electricity. Today we are going to talk about the static electricity. Current electricity means generally the study of the charges in motion and their effects. Electrostatics or static electricity means the study of charges at rest. So today we are going to learn something about that. So be ready. Let me tell you, the first question which always comes to our mind is why we have to learn this topic. There's so many real life examples, daily life examples which motivate us to learn this topic. Let me tell you that right now if you are watching this video, then you must understand that there is a cell inside your mobile which is giving electricity to your mobile. Right now if I'm talking, some of my muscles are contracting, and that is due to electricity inside those muscles. My heart is beating right now. It's because, again, electricity. If I'm thinking, it's because of electricity. So you can see that this thing is possible only because of electricity. It's very important. It plays very important role in our life. I would like to start with an incident in America somewhere in 1990s. There was a tanker, oil tanker. They call it gasoline tanker. It filled up and it was heading towards some destination. On the road, it was hitting some good speed, and suddenly the tanker bursted. It blasted, and people didn't had any clue initially what led to because the people who were driving on the same road, they did not see any collision with the tanker. Later there was a camera which showed that the tanker actually traveling very fast. So if the truck is traveling very fast, there is some rubbing between the air and the truck, and that led to some buildup of charge on the truck, and that led to a small spark that is enough to bring the fire into the play, and the truck got bursted. So this is the reason in industries they take extra precautions against static electricity. There's so many daily life applications which we are going to see. Before that, we will see we have to understand the concept of atom. So let's see. So we know that the present day model atom, you can see that inside at the center there is a nucleus. Inside that protons and neutrons exist, and there is an electron cloud around it. The electrons move around it. I will not go briefly into the atom part, but I would like to give you a few details. The mass of proton is 1.67 into 10 to the power of minus 27 kg. Mass of neutron, it's almost same. Mass of electron, 9.1 into 10 to the power of minus 31 kg. It's almost 2000 times greater, less than mass of the proton. And the other things are charge of electron, minus 1.6 into 10 to the power of minus 19 coulomb. And charge of proton, it's the same, but it is having a positive charge. Okay, fine. How it all started? It all started in 600 BC. In 600 BC, humans identified when they were rubbing amber and wood. They identified that this amber is attracting small pieces of leaves. Okay, then they understood there is something called as electricity which could attract. They didn't coin the term electricity, but they know there is something, some force. Okay. And in 16th century, again scientists, they found out there are two kinds of electricity. Okay. Down the line, Benjamin Franklin, the famous kite experiment, you all know it. Now, he was trying to understand about lightning. Lightning, people believed it is the wrath of gods or so, but he busted all the myths, and he said that this lightning is nothing but a spark coming from the clouds to the ground. Okay, fine. This person, he explained this lightning, he simply said that when two clouds they collide, or simply one cloud colliding with air, it can build up charges at the bottom of the cloud, and those charges can burst out like a lightning. That's what this person said, right? And then the same scientist Benjamin Franklin, he talked about those two kinds of electricity. When he was rubbing a glass rod with a silk cloth, he identified that this glass rod is having one kind of electricity and this silk cloth is having another kind of electricity. Later, he didn't know about positive charge and negative charge, but then he only know that there are two kinds of electricity. Okay. Right. Then he also classified materials as conductors and insulators. Today we all know very well that the materials which have free electrons to move, you can see here, these electrons are generally bounded to nucleus, but there are some electrons which can come out of this atom. Those are called as free electrons. So conductors are materials which have free electrons, and insulators are materials without any free electrons. I would better say. Right. So we'll move on from this topic. Now we'll learn the most important part of this topic, that is charge. What is charge? Somebody asked us what is charge. Charge is a fundamental property of material or a body which either create or experience electric and magnetic forces. It is just a fundamental property like mass. Mass will give gravitational force, charge will give electrostatic force. Right. So if we look at the types of charge, we have two kinds of charge, positive and negative. And if we come to the properties of the charges, like charges repel, unlike charges attract. What it means? Same kind of charges, positive, positive, repel, negative, negative, repel. Unlike charges means different kind of charges they attract. Positive and negative attract. Okay, this is simple. Then charge is quantized. Second property, this is very important. Charge does not exist in this nature randomly. Charge is always an integral multiple of the charge of an electron. That is, Q is equal to NE. You can see any charge is an integral multiple of the charge of electron. That is, this N is nothing but integral multiple. It's like 1, 2 and so on. You put any number. Right. So this is about quantization of charge. Next is charge is conserved. Conservation means it is neither created nor destroyed, but it just changes the number from one body to another body. You can see here, I'll give you an example of beta decay. In this beta decay, a neutron generally converts into proton. And in this process, to conserve the charge, an electron is also created. So to conserve the charge, an electron is created here. So let me tell you that if you look at the entire system, no extra charge, additional charge is created there. But if you see individually, a charge is created here. Electron is created, but if you look at the entire system of this beta decay, there's no creation or destruction of any charge. Right. So this is about conservation of charge. Then let me speak about how charge is produced in our bodies. Okay, there are three ways of charge producing: through friction, conduction, and induction. Let me talk to you about friction. We all know when we rub, heat is produced. Similarly, when two materials are rubbed, then the heat is absorbed by the electrons. Electrons starts transferring from one body to another body. A few examples I would like to give you here is, when we take a comb and when we comb our hair, then the comb will acquire some kind of positive charge. And then when we bring that comb to very small, a few pieces of paper. For example, this is the comb, and then we rub this on our hair, then this comb acquires positive charge and this hair acquires negative charge. So now, on bringing a few bits of paper, these bits of paper cling to this comb because this comb got charged. I'll tell you a few examples which you can try at your home. In a dark room, in dry atmosphere, or in winter season especially, when you take off your shirt, if it is nylon it is better. If you take off your shirt in a dark room, standing in front of a mirror, you would see some sparks. That is an indication of static electricity. And you can listen some sounds also. I think you should do this experiment with a friend. That will be fine. Right. I'll give you one more example. Sometimes in the winter season, when we walk on carpet, after walking on carpet, if you touch a metal knob of a door, you get a small shock. So that is again an example of static electricity. Because charges are building when you're walking on the carpet. So there's a friction between your feet and the carpet. Charges are building up. So that charge transfers from your finger to the metal knob and you get a shock. Very nice example of static electricity. Charge can be built up through conduction also. How would I tell you? If suppose you bring a charging body to an uncharged body, if you keep in contact, these charges transfer to this body. This is the way charge can be acquired by a body through conduction. Okay, let's talk about induction. Students, this is my favorite method of getting a charge. Look at this. Let us say we bring a charged body close to an uncharged body. Let us say this is positively charged and this is an uncharged body. There is no contact between them. In conduction we had contact, in friction we have contact between the bodies, but in induction there is no contact. Now let us say this body is brought closer. Now then, in this the atoms are existing and in those electrons will try to come towards this side and the positive lattice ions try to come to the other side. In the same body you can see the net charge is 0, but simply a polarization have taken place. Negative charges come to this side and positive charges come to this side. It is called polarization and this happens because of induction. Okay. So you can see we feel like this part is charged. Since the electrons has come, they are attracted by this positive charge and these positive charges are repelled by this. Okay. So charging can be done in this way also. So these are the three ways. Right. We'll come to the analogy between gravitational force and electrostatic force. Before that, we will learn about the great Coulomb's law. The scientist is a French scientist, Coulomb. So this man actually gave a law about the force existing between the charged bodies. Okay. So let us consider there are two charges, Q1 and Q2, and the distance between them is R. So I have given that as R12, that is the distance between body 1 and body 2. Let us say both are positive charges. Then there is a repulsion force because we have learned like charges repel. Okay. So there is a repulsion between these two bodies. The force F21, that is force on second charged body by first one, is acting in this direction, and force F12 is acting in this direction. Right, there is a repulsion between these two. So Coulomb found out some relation, interesting relation. The force existing between them is given by this term, that is K Q1 Q2 by R square. So that means the force between these two charges is depending on the product of the charges and it is also depending on the distance between them, square of the distance between them. So in this formula, you would see something else also called K. K is a constant which is given by 1 by 4 pi epsilon naught. Its value is 9 into 10 to the power of 9 Newton meter square per Coulomb square. And then in this you can see epsilon naught. Epsilon naught means permittivity of free space. Let me tell you that permittivity is a property which speaks about the medium's allowance of the electric lines into it. Right. Its value is 8.85 into 10 to the power of minus 12 Coulomb square per Newton meter square. Right. So this is how Coulomb gave us a very good understanding about the electric force existing between two charges at rest. Now I would give you very good example of to understand between gravitational force and electrostatic force. Let me tell you, there is a very good relation. We have learned that gravitational force is given by G mm by r square. It is looking very similar to Coulomb's force. There it is given F is equal to K Q1 Q2 by r square. They both look similar, but let me tell you that electrostatic force is very stronger than gravitational force. You know that in this nature there are four forces: gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. So in that, these two, when we compare, gravitational force is a long range force, electrostatic force is very short range force, but electrostatic force is comparatively stronger. I will give you a simple example of that. Let's take two protons. If we take two protons, proton 1, proton 2, if we compare the gravitational force between them, it has some mass, it has some mass. Okay, so the gravitational force between the two protons is nothing but G. G value is 6.67 into 10 to the power of minus 11 into mass of the proton is 1.67 into 10 to the power of minus 27 kg. I'll square it by r square. Let us keep that r square as it is. Then we talk about electrostatic force. When we talk about electrostatic force between these two protons, it is given by K. K value is given as 9 into 10 to the power of 9 into the charge of proton is 1.6 into 10 to the power of minus 19 Coulomb whole square by r square. Now if I take ratio of these two, Fe by Fg, Fe by Fg, then r square and r square get cancelled, and then after doing the calculation I would find out this as 10 to the power of 36, which means electrostatic force is 10 to the power of 36 times the force of the gravitation. You can see here electrostatic force is 10 to the power of 36 times of gravitational force. This itself is an example, right? So this is about the analogy between gravitational force and electrostatic force. I think I would stop here for today. Thank you very much.